because sometimes it can get confusing. So I'll create two columns, one called the function side, one called the inverse side. Does that make sense? All right, let me hand out the notes.
This is very fun. Sorry for trying to steal your thunder.
No.
I know this probably means a lot to you. This is good fun.
They give you this here? Yeah. Then I'm gonna come over here, I review one right away. Let's see. I can't give you this one because I've written all over that one. I should give it to you first. I'm gonna have to print it off real quick, okay? I don't know why I'm one short. Of course, nothing ever works when I'm in a hurry. All right, let me come here. Thanks for your patience. All right. All right, this is what everybody has in front of them. Okay. First of all, right here, when you see x to the negative 1, that means 1 over x. This means, when you see this negative 1 right here, it means the inverse of f of x. 3 ways to say the same thing. G of x is the inverse of f of x. So when you see the AP exam, they'll say it in those words. They'll say G of x equals f with this negative 1. Well, they're saying that's the inverse of f of x. And then there's this one. it's a composition. In fact, this is the official definition of an inverse. That when you compose, when you plug G into F, or plug f of x into G and get x, then those two functions are inverses of each other. Example, we had f equal x squared, we had G equal plus or minus the square root of x. So if I plug G into plus or minus the square root of x, if I plug that in there and I take plus or minus the square root of x and square it, I get x as my answer. You probably did ones like this last year where you said y equals 2x plus 1, and then you said, okay, to figure that out, I'm going to say x equals 2y plus 1. So what you're doing is exchanging the domain and range, correct?
I'm gonna be writing stuff down.
And so I'm going to get x minus 1 divided by 2 is equal to y, and if I put that into here, I would get x and vice versa. All right?
Okay, I did not understand what you were saying.
Okay, so what I'm saying here, this is what you told me before, right? Didn't you interchange the x and the y to
Yep.
get the inverse?
Yep.
Okay, that's what I did here, and then I solved for y. And so these two expressions are inverses of each other. If I would take this expression and replace x with it, I would get x as my answer. And likewise, if I take this expression and put it into this x, I'll get x as my answer. I think you can see that I would take 2 times this, I would get x minus 1, and x minus 1 plus 1 would be x. Likewise, if I put this 2x plus 1 into here, I'd have 2x plus 1 minus 1, that would give me 2x, and 2x divided by 2 would be x. Everybody okay on that? I don't want to spend a lot of time on it.
So if you add the two functions together, they would equal x.
If you compose each of those functions,
So fog and both fog and golf.
correct, we'll
Will
give
both
you
equal
x.
x.
Yeah.
We're both.
Okay? All right, so the derivative of this is going to be 1 over the derivative of f. The derivative of the inverse, oops, I made one tiny mistake. There's one mistake and I'm going to have to fix it. This is not correct. Oh, how do I want to say this? Without it being confusing. I'm gonna write it like this. Yeah, I'm gonna write it like this. It's still gonna be confusing. All right, let me show you what I mean. Okay, the table below gives values of a differential functions f, g, and f prime at the selected values. And then it tells you this: let g of x be the inverse of f. And the first thing it asks is, what's the value of the derivative? So this is what I do. I create a little separation. This side is f, this side is g. And I write inverse over here. And over here, I'm going to have x equals 1, because there's a 1 in here. So the question is, what is g of 1? So I come over here, 1 over here means that over here, y is equal to 1. Would you agree with that? Because the x values on the inverse are the y values on the function. So that means f of x equals 1. So I go to my table, here's f of x. I look to see where I got a 1. I have a 1 right here. So f of 2 equals 1. So if I put 2 into f, I'll get 1 as my answer, correct? Then what I do is I say, okay, what's the derivative of 2? The derivative of 2 is a negative 2. Well, remember when Matthew was so excited? Because he says, oh, it's 80. I already know what it is over here. There isn't any math to do. Well, there is, but it's real simple math. Because over here, I'm going to, first of all, this was 2. The derivative of g with 1 put into it is going to be what? The reciprocal of that negative 2, the negative 1/2. Now, here's something that I want to show you. What do I get when I multiply these two together? 1. You notice right here it equals x, correct? What's the derivative of x? 1. And that's why that relationship is.
So if the derivative is multiplied together, they should equal 1.
Correct. And the other thing is I don't know if you learned this last year, but a function and its inverses are their reflection over the y equals x line. Did you ever learn that? Okay. So if you can draw a 1, I always draw in the y equals x, which is just a line that goes at 45 degrees, and then I just reflect it over that line. All right, so it says write an equation for the line tangent to the inverse. So I could put g right here if I wanted to. Write an equation for the line tangent to g at x equals 1. Well, I need what 2 things, Austin, to come up with a line?
Point and slope.
Point and slope. So one of my points is 1 comma what?
2.
Is he right? Here's the inverse. Here's f inverse. So do I have the point 1 comma 2 right here?
Yeah.
Yeah, 1 comma 2. So right now I know I got x minus 1 plus 2, and I need the slope at 1. Do I have the slope at 1?
Yeah, is it -3?
No. It's right here.
Yeah.
Okay, because that's the inverse. So I have a negative 1/2. Okay? All right, let's take a look at this one. It says let g be a differential function such that g of 12 equals 4, g of 3 equals 6, g prime of 12 equals a -5, and g prime of 3 equals a -2. I already got a headache. That's way too much stuff, Colin. It's scaring the bejeebers out of me. All right? It says the function h is differentiable, and h is the inverse. It tells me this right here. It's the inverse. So when I see that, Jonah, I say, all right, I'm drawing a line here. On this side I have g. On this side I have h. And what is h? It's the inverse. You'll see me do this every single time to organize my stuff. So now I know I have these points. 12, 4, 3, 6. The derivative of 12 is equal to a -5, and the derivative of 3 is equal to a -2. And then over here it says, what's h prime of 6? So what I do is I come over here and the first thing I do is, okay, what's h of 6? And if I know that, I can find h prime of 6. So, x equals 6. Correct? On this side, I'm on the inverse side. X is equal to 6. But when I bring this 6 and I bring it over here, x no longer equals 6, does it? That 6 becomes a what? A y. Why? You ask? Again, that was humor, Audrey. Okay. Richard, Mrs. Benson's not that funny. Okay. Why? Because inverse and functions are simply them being switched around. So I'm going to switch them back, and I'm going to say y equals 6. So I look over here on G, is there any place where y equals 6?
X equals 3.
X equals 3. So what's h of 6? It's equal to 3. What do I look at to find h prime of 6? Well, I look for g prime of 3. And that's a -2. So over here it's going to be a negative what?
1/2.
-1/2. The hard part isn't making a reciprocal. The hard part is organizing the numbers. We doing okay? All right. Right here, number 4. And it doesn't ask for a tangent line, it just wants to know the slope. It says, if f of x is equal to 3x cubed plus 1, and g is the inverse. So over here, I'm going to write 3x cubed plus 1. And over here, this is equal to f. And over here, I have g. And what is g? G is the inverse. And it says, all right, what's g prime of 25? Equals what? Well, I need to know what g of 25 is. That means x is equal to 25. You see all the stuff I write? And then I'm going to come over here, and what is that 25 going to become?
A y.
It's going to become a y, correct? Now, am I going to put 25 in for x here? No, because it's a y. It's not an x. It's only an x on this side. When it comes over here and wanders over here, it's now like a y. Okay, I'm going to confess something. You are the only class I've ever told this to, because I'm very sensitive about it. My dad had sisters. They were my aunts. And when they were little, they called me Chucky. I hated it. But they were my aunts. And I was told to love them and respect them. And they were beautiful people. Okay? But every place else, I was Chuck. But when I moved into their world, I became Chucky. Even when I was 35 years old. Because they're thinking I'm still 4. Moving from one world to another. This 25 is an X, on this side it's a Y. Now, do I have a way that we figured out 25? I'm not going to put it, I'm going to take this 3x cubed plus 1 and make it equal to 25. That means 3x cubed is equal to 24. That means x cubed is equal to 8. That means x over here is equal to what? 2. So over here, g of 25 is equal to 2. Now I need this 2 to come up with a slope on this side, correct? I need this 2. I don't wanna go through all the work and come up with the inverse for this. I don't need to, because this is a pretty easy derivative to figure out. What is that derivative, Matthew?
Derivative.
Of f?
Oh, that would be 36.
Okay, yeah, you're going too far. Just do the power rule here first.
Oh,
You're right,
that would be 9x squared.
okay, and then you're gonna put a 2 in there, right?
You get
That's
10.
what I need that 2 for, is to come up with that 36.
Yep.
But that's on the function side, Colin, not on the inverse side. When it comes over here, it's gonna become a what?
1 over that.
1 over 36. Not hard math, but it can be confusing. So I divide, all right, when it gives me this question, it says, and it'll look like this. I'll give you another one. It'll say, it'll give you a little table. And they'll have, let me randomly pick a number, I'll pick 3. And let me take a derivative, let me pick a number 27. Okay? And then they'll say G is equal to F inverse. What's the derivative of G at X equals 3? Well, what is this talking about?
1 over 27.
It's talking about the inverse side, isn't it? So what I do is this side I write G and I write inverse. And this side I call F. I know what point is 1 comma 3. I know F prime of 1 is equal to 27. Over here it's going to be 3 comma 1. This X is the 3 in the inverse. So that G prime of 3 is going to be 1 over 27.